Hello, everyone. Come on back for our final presentation. So, I hope you have saved all of your questions for the 5 smartest people in the room, and me. So, what this portion is going to consist of is essentially it's a panel, and it's going to be an open conversation. So I'm Leo. I'm going to be the MC. So I'll be facilitating the conversation with our panelists. But we want you to participate. So whatever questions that you've been thinking of, be ready. We're going to throw you this box over here, so you can ask the question. If you don't want to ask the question into a box, just go ahead, write it down on a piece of sheet of paper, and send it off to the side. And Feeny over there will grab it and send it up to us. So that's how we're going to work it. So let me go ahead and introduce our panelists today. So first off, we have Davis Purcell with Pennington County. And, sorry,
Yeah, you already introduced me, so.
And we have, what is your last name? Michael N. Treader with UNF.
Yep.
We have Austin Pleasance with Q-PAC. We've met Matt Kent, our CEO. And we have Kevin Fulton with AMCA. So, we're going to give it up, yes. So, I'm just going to open up right now. We're going to start this conversation, but what I want you guys to think of is anything. But the very first question I have is about air handlers, right? We're manufacturing a new type of fan for your air handler. And so we get this a lot. What's going to be the biggest difference between a Q-PAC system, what we're building, the Multimotor Plenum Fan, and a fan array, right? So if we kind of look at this from a couple different perspectives. So I would like an answer from both Austin and Matt. Very quick, what's a fan array, what's a Multimotor Plenum Fan? But then again, I also want to ask our users, do they understand? What is it that they think of? So that's the first question. Who wants to go first?
Okay.
All right, Austin, go ahead.
Cool. So for me, a fan array is when you have multiple fans working together in a single airstream. And a multi-motor plenum fan is different from that because it's a single fan. And the reason I say it's a single fan is because all of the components are designed to work together, and there's a single point of power and controls, single input, single connection point for your BMS. And to me, that's the main difference. You want to expound on that? Matt's going last.
Sure, I'll take it. All right, so from an end user, basically the way that I look at it is reliability. If we lose one of the fans within the multi-motor plenum fan array, we're still able to run the unit. We don't lose the entire unit. So for us as an end user, it's the resilience and the reliability.
Yeah, I would just tag on to that to say that redundancy is a huge aspect of what we look at in our county because we have 24/7 facilities that we're operating out of all the time. One of those, actually 2 facilities are a jail, so it's basically inmates that live in a hotel. We have to have redundancy and reliability, so to be able to change out a single fan in a multi-array fan system is huge for us.
I'd like to point out that Davis is not with the tourism board, and you do not want to go to any of his hotels and/or jails.
From an AMCA perspective, I think it's putting on my testing hat. It's just a different way we test. It's testing differently, but testing the same. We have a array that with a 270 testing is one way to test, and then if it's a single fan, that we have a different way of testing. So from my perspective, I don't think I share the same concept as you guys. Right?
Thank you.
So it's like once I got locked on this, I started seeing it every week I find an example of the exact same thing. I mean, this week I found one. I learned what a modular boiler is. I don't know if anybody of you have ever worked on one, but it's basically an array of boilers that is one single boiler, just like a battery on your drill. we've got probably, I don't know, 100 Milwaukees in this factory. We call the battery a battery because it makes sense and it charges. And inside of that battery is a set or an array of smaller batteries, and it has a controller sitting on top of the array of batteries, and it makes a single battery. And it's just a language thing. And I've actually gotten kind of comfortable with the uncomfortable, that we're just going to have to kind of push the limits. But I think for me, building arrays for 10 years and where we're at as a company, we're at kind of a defining moment. Becoming an AMCA member, building an airflow tunnel, sheet metal and plug fans and wires, and then this junction box that we invented that started out as a junction box. It all comes together when we build fan curves that are unique to the MPF architecture, right? Which is coming soon. The two major things that I'm looking for really in the near future are fan curves that are irreplicable, like they cannot be replaced or other than making the MPF architecture, you cannot create them, will be coming soon. And then also what you saw back there with the single assembly, being able to ship the fan as a single unit in mass production scenarios for air handlers. I think over time, as we keep innovating, it'll become more clear. And actually, I'm comfortable with it being a little bit unclear right now, but yeah.
Thank you. So, did that jog anything out of anybody? All right. Oh, yes, one.
Is this a microphone?
Yeah.
Are you going to be moving away from the term array when you describe the fan array?
Am I on? I personally don't have a problem with it because I'm an engineer, and just like the array of batteries is converted to a single battery, it's a concept, like an array of something, right? We write code, we write lots of software. Arrays are it's a term that should be used wherever it's applicable. What we're really doing is we're taking fan array. Fan array has kind of multiple meanings, right? Our industry has adopted it as like in a category. Like it's kind of nuanced, right? There's fan array as the basic understanding of an array of fans, but then there's fan array as an actual category that's been kind of promoted for 20 years. So there's two versions, but from a conceptual perspective, all we're really doing is we're taking a fan array as a concept, and we're compressing it down into one new fan. And there's many versions of this in our world. I mean, a tower fan that's inside your bedroom that's cooling you on Amazon.com, it has an array of fans inside of it. And just like a battery, many architectures use building blocks to make the large thing. So no, I use array. It's not like some banished word, and it doesn't offend me, because yeah, it's just languaging is tricky. We're learning how to become marketers. Yeah.
That was kind of my point and my hope, is that if we had some common language around how to talk about the product, because what I heard was, well, it's one fan and one control, but then it's still an array. And for those folks who've been in the industry for a while, it can be confusing because it's like, well, is it one fan? Because then it also loses some of the differentiation that both of you guys talked about, right? Like the things that stuck out to you were the resiliency, the redundancy, and the reliability. So how do we talk about the product in a way where it is new and different, but also maintain some of the unique differentiators that end users are looking for?
Right. Yeah. I mean, depending on who you're talking to, so if you're with me and we're over in R&D with Ken, I mean, we're talking in engineering speak in the term array. If you're with an end customer, I mean, and I've tested this on electrical contractors and mechanical contractors and end users. The single fan, it cuts through so much noise, right? Because the moment you say an array of anything to someone who's not participating in the design of the thing, it can get really complicated. I mean, who wants 9 fans? That's why our philosophy is that the customer really only wants one fan. The issue wasn't that they wanted more fans. The issue is that they want it to be reliable. So we're trying to deliver the most reliable fan like that's ever existed for air handlers. How we accomplish that is very similar to many products in the world where they use smaller units of the same thing. So it depends on who you're talking to. But that's why we invented the multimotor plenum fan. It is a type of plenum fan, right? That by using the term plenum fan, you kind of imply that it's going in an air handler. And the motor itself is the critical part that's gonna like fail, right? And so, I don't know.
So, reliability. That's what we keep talking about. What's the opposite of reliability? Failure. So we've all dealt with failure in the field. And so I'm not sure if you guys are aware of this, but at Q-PAC, one of the things we can do is that 6-pack, we can kick it out the door in one day. So we have your quick build option. So when you have a failure, you can look like rock stars in front of your customers. So we can do that in a day. A 9-pack, we can do in 48 hours, 2 days. So I want you guys to kind of think about that because I'm going to ask Michael here about a failure that he's had on his campus recently at UNF.
So at our golf learning center that we have on campus, excuse me, we showed up on Monday and the squirrel cage over the weekend decided to eat itself. Squirrel cages are not on the shelf anymore. You can't get them quickly, and eventually they fail. So what we did, we reached out to our contractor and said, what can you do? Can you find us something? Well, he called Q-PAC, and in 12 hours, we had a fan wall and a single fan, and we were back up and running. So that's how quickly they were able to get it to us. We're very lucky that we happen to be, half hour, 45 minutes north of you guys. So that is also to our benefit, but at the same time, it just shows that they dropped everything, moved us up to the front because we told them, we'll pay for the expedite. We need this back up. We do have labs in our golf learning center for our energy programs and whatnot. So we needed that unit back up and running that day. So that's why we did it. But within 12 hours, we had that unit back up and running.
That's awesome. Davis, I do want to ask you, in your illustrious half-star hotel, and you were to experience a failure, what would it take to get you guys back up and running with your current technology?
A lot of phone calls. It would take time. We actually right now have a 250-ton chiller that is part of our redundancy that is out. So if we lost the other 250-ton chiller, we'd be scratching and clawing. And my analogy with the hotel goes even deeper is because if you think about it, there's actually accreditation standards for jails now. And so the inmates have a right to a standard for temperature variations and things like that. So it's not that we can't function without it, but we'll actually create lawsuits and things like that from the inmates if we are down too long and for a long period of time. So again, I don't have any of these systems yet. Any of these Q-PAC systems. I heard about it about 3 to 4 months ago when Aaron came out to South Dakota. He pretty much sold me then, and then Climate Control brought me out here, and it's been a real eye-opener. But as far as any sort of reliability and redundancy, it's even more than that. It's the fact that we can't function without cool air or even warm air for that aspect. But
So one of the really cool things about a Q-PAC system when it's been installed is the resiliency, and we talk a lot about that. And one of the really neat things is, I hope that you guys have had the ability and the chance to kind of look at and to poke at the product and try to find a single point of failure. And we used to have one in a previous generation, but now that's been engineered out. And so I'd like Austin to talk a little bit about our fan controller and some of the new things that we've done to eliminate that single point of failure so you don't have that problem to create a lawsuit or to have a temperature control, or if you're working in a hospital, that your OR goes down.
Yeah, so one of the potential downsides to consolidating this technology that used to exist in multiple different motors and consolidating it down to a single point is that you could accidentally introduce a new single point of failure that didn't exist prior. And so when we went down this road, we wanted to make sure we didn't accidentally do that. And Kane's team, the electronics team, they took it a big challenge on their end to design the entire circuit to the point that even if something were to fail, any component inside that board were to fail, the 0 to 10 volt signal that you're sending it would bypass all the electronics, bypass all of the brains and everything, and still make it out to the motors. So worst case scenario, the 0 to 10 volt signal that you're sending it is still going to make it to those motors. I've challenged Kane and the Watt Wizards to create a marketing video for me where they take the fan controller, open it up. I want them to hit the board with a hammer, drop it on the ground, pour some water on it, and still zoom out, and the fans are still spinning. That's the level of detail and robustness that we're requiring out of our product.
Is there an AMCA certification for that? Not yet. Got it. But let's talk. Anybody you want to expound failures? Okay, cool. We'll move on. Talking about failures and resiliency and redundancy, we also know that you guys as the owners and end users are having a problem with labor shortages and finding the skilled labor to actually maintain your current systems. So I'd love to hear from both of you guys, Michael and Davis. How is that impacting you? What are you doing to mitigate that outside of the Q-PAC and just with your entire facilities? How is that looking?
Yeah, I mean, tradesman is a dying word, in my opinion. I think there's some unions and things like that are getting after the younger generation to try to create more plumbers, more electricians, more certified HVAC technicians. And that's another thing about this product that really stands out is the serviceability of it is if a fan goes down, I don't need any sort of certified technician to be able to swap it out. I could just ask one of my maintenance technicians to do it. But I think that's a problem that everyone's going to find. We have our own plumbers, electricians, and HVAC techs in-house. When our electrician of 32 years quit, it took us a year to get another electrician. We're still actively trying to hire a plumber after 6 months. Fortunately, our HVAC technicians have all been with our company or with the county for 25 years, but that institutional knowledge is really just stuck with those guys, and it's not really passed down to generations. And that's sort of a culture I'm trying to create within the county, is to pass that down just to our maintenance techs so they can understand these systems. But that's a huge piece that stuck out with this Q-PAC system is to be able to swap it out so simply.
So I'm going to piggyback on that. It is very, very hard, even down here in Florida, to find qualified plumbers, electricians, technicians, basically anything. For us, I currently have 2 controls techs that have been with UNF 15 plus years. They have a ton of institutional knowledge, and within the next year to year and a half, I know for a fact both of them are walking out the door. I'm very lucky to have just hired a 3rd controls tech, and I've basically told him, you need to learn everything that these 2 guys know. And I hope that he can do it. He seems to be doing pretty well so far. But with this system, just maybe a month ago or so, me and 2 technicians, we swapped out 4 fans in about 30 minutes. So really straightforward, no specialty tools needed. You can do it with a ratchet, but if you have an impact gun, it just makes it even quicker. That's about it. That's all you need. So, yeah, it's a really simple system to swap out when you do have issues.
I think the record of our fan swap is, I know it's typically done under 2 minutes, but we've had a record of a team doing it in about 58 seconds. That quick. So from a maintenance standpoint, it's pretty inexpensive. Can you charge your guys by the minute?
I wish. One of the other things, too, when you do go into the warranty claim, normally we order a lot of our product through a supplier, not directly from Q-PAC. There is a checklist of stuff that they do ask, and it's very thorough, and we've caught 1 or 2 fans where it's actually just been a fuse or something like that, and just going through that checklist helps, that they have us do to get through the warranty process. So everything is covered.
So I'm glad you mentioned the warranty because Q-PAC, I hope everyone is aware, we have a 5-year warranty, 5-year parts only. And so if that motor fails and we find out it's within those parameters, you're getting a free motor. So do you now have to stock a motor on your shelves?
No, I don't. I mean, for us, and we've talked about possibly standardizing around a certain size for campus to be able to stock on shelf. But at the same time, we're very lucky. We're 30 to 45 minutes away. We don't need to have it on the shelf because you guys do. So we're lucky in that regard. But for places that aren't as close as we are, if you standardize on one, yeah, you can put them on the shelf. But the warranty process, more than likely, you'll have it next week. And I would say if you have any sort of array over 4 fans, you're more than likely running with very minimal performance losses. I mean, if you're only having 2 fans, obviously you're going to lose 50%. But if you're 4 and up, I don't see why you would need to put anything on the shelf and just wait for your warranty to go through.
So as you're talking about your teams, your maintenance teams, you know, when I hear people, it's labor, right? What can we do to help you quantify that labor savings? What have you seen as a quantifiable labor savings? And then you as a potential customer, how are you anticipating some of these labor savings?
All right, so labor savings. When you put these systems in, I no longer have to worry about belts, grease, bearings, pillow blocks, squirrel cages where they can throw the weights and unbalance themselves and then eventually eat themselves, all sorts of stuff like that. That whole day's worth of PMs, I can take that labor time and I can put it on something else. So that frees up one of my mechanics, because right now on a day shift, I only have 3 and I have 1 in training. I got 2 in the afternoon and 1 at night right now. So that's where I'm at as far as labor goes. So if I can use that labor the most efficient way possible, and this helps me get there, it's a home run.
Yeah, I'd agree. To me, it seems like a system that you install and you walk away from. You only really need to come back to it maybe when it's having issues. And if we can reduce the number of gantry devices we have around our facilities, I think that would be really beneficial. Obviously, we still have pumps and other things for our vacuum system and plumbing systems and things like that. But to me, yeah, I mean, again, the serviceability of it is bar none, in my opinion. So
actually, to add to that, he said gantry systems. Think about it. If you got a 100 horsepower motor, we all know what one of them weighs. Trying to get that in and out of an air handler just is not always the most feasible. So if you got one of the smaller units, I mean, we did 3 across the bottom and we swapped out 4. And then we went and did the top one. I picked it up, I put it up on the ledge, and another guy screwed it in. And that was it. So we were very lucky that we were able to do it because of it's just really easy and convenient.
Nice. I had a thought a moment ago, and it just left, so I'm trying my best to claw it back into my brain, because it was a bit more of a crowd participation. And I kind of want to talk a little bit about, with the labor savings and the installation. There we go. Now it just came back. You had mentioned that it seems like a system that you set it and forget it. And over here in our crowd, we have lots of customers that have been working with us for a while. Thank you very much. We appreciate that. So is it really, and I ask you guys, and so one of you got to pop up your hands. I see a few people I know that can answer this question. Is it truly a set it and forget it mentality of, after you've installed your Q-PAC system, I'm done? Or after I've installed my Q-PAC system, I need to go back and I have to work with Q-PAC's amazing technical support because someone didn't install it properly? What is it? I will call. Thank you, John.
So our first retrofit that we installed was in 2017, and to the best of my knowledge, there's been no problems, and it's still running today. So that's been a long time ago. That's way before FS1, and we have probably hundreds of units right now that I don't get callbacks at all for. So, yeah.
Hundreds. Lots. right? So that's going to speak to the efficiency and the reliability. John, not John. I'm sorry, Michael. You're not seeing problems, right?
Nothing that we can't handle, nothing that you guys haven't been more than willing to help us out with.
If you do have a problem, you're not going to mention it now, right?
Sure. No, problems have been very limited. If anything, it's just a motor fail on a fan. Outside of that, the programming, the controls, everything else has been wonderful. We've had no issues with any of that. At the end of the day, it's really just been a fan or two that we've had to swap out. And sometimes, like I said earlier, it's just been a fuse.
So I'm going to try to move this conversation again a little bit. So new technology. A lot of people are afraid to try something new. They don't want to be the first person on the block to try something new. And we keep saying, this is a new type of fan. The multi-motor plenum fan is something different. It looks a whole lot like what's already out there. That's only because it's big. It's a big box that we can look into, right? So when we're talking about adaptations of new technology, and Kevin, I kind of want to throw this one over to you. What are you seeing in the marketplace for adaptations in new technology, adaptations in fans, right? So as the certifier, you get to see what everybody is coming up with. So what are you seeing that's new in the new technology standpoint? And then I'm also want to kick this back to the two of you saying, all right, from a new technology standpoint, what are your trepidations of not wanting to implement the new technology and just stick with what feels comfortable? And then versus, no, we need to move forward on something new. So that's what I want you two to kind of think of. And then Kevin, again, just kind of expound on what you're seeing new in the marketplace.
Yeah, sure. As you know, like a fan is, it's not fans aren't cutting edge, changing from week to week, year to year. Our members are continually tweaking their current products. And I'll be honest, not just because I'm sitting here with Matt. What you guys are doing is it's cutting edge. It's pretty cool. Not everybody's doing this. I mean, you guys think about, you guys are building, I think I heard, an array in 3 hours, and you had it delivered in 12 hours. You guys are building fans that are fresher than the eggs in your refrigerator, right? I mean, Did
anyone pay you to say that just now?
No,
Okay, so
no,
I want to make
not
sure
at all.
everybody knows that.
And so even when we're planning with Shruti to come here, it was exciting, it was live, it was fresh. There's an energy, and that I think what you're doing to the industry is great. You know, kind of disrupting the industry a little bit, and it's impressive. From like new technologies, cutting edge technologies, I wish I could say that they were knocking down our door. We always have members recataloging, refurbishing their fans, but for the most part, it's you guys are it.
Pretty boring.
It's really
Fans are
hard-
really boring.
It's really hard to change the laws of physics too, isn't it?
Fans are really boring. So yeah, we're definitely we're making it more exciting. A whole event dedicated to fans, just for air handlers too, because fans are freaking everywhere as well. And just to be clear about my earlier conversation, and thanks for asking Ashley and poking. I don't expect people to. I mean, we're crazy, and we think about language and words and I mean the human element of the whole thing, right? How do you communicate? And we're constantly testing and evolving. This is the beginning. I know. I mean, it's cool because we have so much experience. I mean, over a decade, but we really are kind of at the start of something. It's really gonna take shape in years to come. So we want to be reasonable about how forward thinking we're thinking in how people may receive it and adopt it. So, yeah. But I'd love to hear some questions and hear what's going through all your minds out there.
All right, so for me, for the adaptation part, bringing in new technology, I mentioned earlier that I have 2 controls techs that have been with us 15 plus years, and they're both in their 60s. So getting them to, want to dive in and learn a whole new system that is so different from what they're used to is hard. For me, I'm 35. I'm very open to all this sort of stuff and bringing on new equipment, new technology, anything that can help us advance. But to ask them, hey, you've been doing it this way for the last 25 years of your career, and for the last 3 years of your career, I want you to completely change that and do it differently. It's not always the easiest thing to sell to your guys. So when you do bring on new technology, new equipment like this, for me, the biggest thing that I found is making sure that you get as much training on it for these guys as possible and get them to feel as comfortable as possible up front, so that when they have to go in there and start working on it, they at least have some training and they can then use that and get the hands-on skills and everything else once it's on site.
Yeah, just real quickly. So I was thinking about it. I think I have 8 people in my department, which is roughly 55 employees total. 8 of them have been here, and 8 of them just on the maintenance side, which is about half of my employees, so about 25 of them. 8 of them have been here for 25 plus years. And so it's almost voodoo when you say, yeah, this is new technology. Like, they'll pretty much scoff and walk away. But I think if you can introduce something that's simple, and like he was saying, you train them on it, but if the training isn't too difficult, it'll open their eyes. Because a lot of times what it seems like is when you start to introduce more technology, sometimes it can be more difficult to understand. And that's where this product stands out to me, because it's not more difficult to understand. It's almost too easy. Like when I heard the pitch the first time, I was like, this can't be real. And Dave, my assistant director, and I looked at each other, and he's my mechanical guy, and he's been at the county for 25 years, and we just kind of looked at each other and went, holy shit. And we're like, this is pretty cool. So.
Go ahead, Matt.
I haven't said it today, but fan arrays are incredibly complicated systems, and that's one of the reasons and catalysts for us having to think differently about how to language this category and start something fresh, because fan arrays really are very complicated. I mean, Natalie meant it earlier when she said that people call when their airflow's down. I mean, our product support team gets calls from customers that don't even own our product. I mean, it's very interesting to get on the line, on the phone with people that have come to their final, last hope in getting help after all their other paths. They don't even own our product, and they're like, what do I do with this thing? And a lot of times, it's some type of fan array that's a recent entry. It's not even old, because we know how to work on those. I mean, if it's a 100 horsepower motor, it's not like it's foreign. We have a hard time finding people that are skilled enough and want to do the work, but I think there's an avalanche occurring right now in the fan array space that we see, because we have different lenses than other people, and a lot of adoption is happening from an ECM perspective. They're becoming very popular, but I don't think end users are going to like how it pans out. I think every single permutation of fan arrays in the world are all one of a kind, and we're trying to build like a whole new architecture that can, people can actually be trained on and understand.
So I can expand on that a little bit from the end user, because we do have a couple fan arrays that are 9-fan, 30 horsepower motors that still have the old controls where they had ice cube relays and everything else, and every single fan has its own CT to make sure it's running and all that sort of stuff. And just the way that they've been able to engineer through all that and simplify it is really what makes this product stand out to an end user like myself.
It's really good. So have you noticed, as you walk around Q-PAC, we're not necessarily afraid of technology, and we're not necessarily afraid to invent new things. So I kind of want to ask Matt and Austin to expand on what are some of the new technologies that we are implementing within the Q-PAC Multimotor Plenum Fan. And then as you kind of guys talk about that, I want Kevin, Michael, and Davis to think about what they said and either confirm or call BS, right? Like, because we have a vision and we have an idea of where we think we should go, but as you guys, as our customers, and I'm going to call you the referee, okay, Kevin? As the referee in the marketplace, how does that line up with what you guys are seeing and what you guys expect the future to be? It's fair to say that we're all pretty young here at Q-PAC, and everyone still has a lot of years left in their career, and how is it going to move forward? So, Matt and Austin, take it away.
Yeah, so in the beginning, when I first started here, a lot of our technological developments were all focused around the theme of simplicity to install. So we designed things like the fan ledge that holds the weight of the plug fan as you're putting it on the wall. We were putting things in like the riv nuts, so you're not having to hold the nut on the backside of the bolt while you're installing. how the fan frame comes together and squeezes the panels together to eliminate the gaps at the top and the bottom. Things like that was what we were really focused on in the beginning, and we think we did a pretty good job with that. But like Matt was mentioning earlier, we're entering a whole new era of technological development. It's insane to look across the aisle in the engineering area over here and see these firmware developers and electronics engineers designing these 8-layer PCBs with all the traces and all the microcontrollers, and I used to understand our product inside and out. I knew every single subcomponent, how it worked, and that PCB over there, it's throwing me for a loop a little bit to catch up to what they're doing. But that development was just a platform for us to be able to add new features. Right now, if you look at our product from about a year ago until now, not much has changed on the feature side. A lot of the inside guts have changed that allow us to take it to the next level. So you may not know this, but there's an accelerometer inside the new fan controller on the main board.
I did not. Is that, if someone gets, oh no, is this for shipping? To find out if it's busted before it gets there?
No, not quite, not quite.
Is it to hit your coworker over the head?
Yeah. No, so we included a bunch of new sensors on this board that we might not even have a plan for when we put it on there, but we knew that we might want to use it one day, so we went ahead and included that sensor, so that way eventually it could just be a software update where it unlocks new features. The accelerometer in particular could, in the future, help you avoid vibration issues. You hit a certain frequency and the wall might start shaking. We don't know. We haven't seen it, but that accelerometer is just another sensor that allows you to potentially avoid certain frequencies or detect when a motor is about to fail or things like that. So that's some of the technological development we're doing on this new platform that we designed last year.
There's like so many to think about. And I want to go back to what Austin said earlier. It's really cool to talk about these features, and we're very nerdy about them, but we got to be clear here, okay? It's about resiliency. If any of them compromise the fact that this thing needs to move air, like, it's out. Like, it's unacceptable. I mean, it needs to be in its rawest state. It is taking electrons and moving air and meeting the duty point, period. Everything else is just added on top, and they're great. Like the accelerometer, if there's, I'll just give you an example. If the installer forgets, because it's a contractor, I mean, things happen. What if they forget to put, 30 of the screws around the perimeter, right? Well, Eric talked to you about our OSHPOD test earlier, OSP for seismic. I wish he would have showed the video. Did he show the video? No, he didn't show it. It's crazy. Shakings, I don't want to be part of earthquakes. If that were to happen, you forget part of the installation, then you're in a situation where you may turn this thing on and destroy it. The accelerometer would prevent things like that during the commissioning process and be able to create an alarm because the system should not be vibrating. So it's an added feature. That's one. I don't know, Austin picked one. There's hundreds, and this is what we would consider the discovery phase of development. It's why we need an R&D center. It is ideating. It is being curious. It's got to be battle tested and before it ever hits the market. For me, there's just a lot that I'm very excited to explore. What I love is the idea of taking all the best things that fan array innovation over the last 20 years has accomplished and just trying to remove all of the things that are bad about it, the complexity, and try to find a scenario that is a win-win where you get all the best of what a fan array brings and all of the best of what a single fan brings. For instance, I was talking to some of the people in the R&D area, when you're sizing a fan array, you always you add an additional fan to the system, and you have to have the consequence of that. You have to have larger conductors, larger wires, larger conduit, because you added another motor. In the MPF, the way we're going to design it, it may have an additional motor in the system, but from a specification perspective, it only needs to use that added mechanical component when it needs it. So you'll be able to see, you know, where a fan array might say 50 or 60 amps on a schedule, or an MPF might be 50 amp, or, you know, an array might be 60 amps and the MPF might be 50 amps. I mean, it seems minor, but we're able to reduce the total cost of the fan system by not having that burden. So there's a million of those. I mean, there's so many things that could be unlocked. And like I said, we're at the very beginning. Yeah.
So the second part was, how's it? What is the technology? Well, do you guys remember what the second part of the question was? Yeah. Okay, never mind.
I mean, sort of, but for me, it's like I'm from South Dakota, so when I walk into a place like this, I've never seen anything like this in my life. It's like, I guess in layman's terms, it would be like if they opened a gas station and the gas station had a liquor store. I'd be like, oh wow, that's crazy.
Sounds like a problem.
Well,
Fine,
no,
but
not for
could
me.
be a
I'm just
problem.
saying in general. But when I walked in here, I just couldn't. I was like oohing and awing over everything, and it's just very cool that a lot of what you guys do is in house, and it's like a very techie startup. To me, I've only seen it in like movies and things like that, so it's a real eye opener for me to get out here and actually see it in person.
So I'm originally from New York, worked in New York City for a bunch of different power plants. So I've seen stuff similar to this, but to the same point, being that they have R&D and the testing and everything else all under one roof, and everyone working together from the people on the floor to the engineers to R&D, it's really, at the end of the day, probably going to create a really, really great product on top of already what they're able to bring to the end user. So for me, though, one of the things that was spoken about earlier with the accelerometer, maybe using that during commissioning to make sure that the install process was fully finished. As an end user, I don't want to have to go backwards and say, hey, this is now 2 weeks pushed because during install they left out screws and now it's destroyed itself and we need to wait for new parts. So something like that really could be helpful to us at the end of the day.
All right, from my perspective from AMCA, when I talk about development, technology, I guess our contribution would be on the standard development, part of the process. The challenge I see, currently, is to develop a standard, to enhance a standard, to make a standard better. It could be, 12 months, 18 months, potentially 2 years. Once you develop a working group, develop a committee, then you put the draft out for comments. You have 15 to 20 fan manufacturers on the standards committee. It's just a process. The 270 standard just got completed, and yesterday he was already talking about, what he wants to do next. So part of the challenge that AMCA has to have is how does the standard process keep up with the development and the advancement of the technology at the pace that our members are moving. Right now, the standards process, it's not built that way. So we have to figure that out.
Thanks, guys. So we're coming up on our time, and I've asked a lot of questions, and I think these guys have talked a lot. So we have about 5 minutes, and we're not going to sit here completely silent. Somebody's going to have to ask a question. Yes, my man.
So you guys have stated your go-to-market strategy, right? So your hopes is that anyone can install this system. What is your plan, or what do you have set in place to ensure that the product is installed correctly and that Q-PAC isn't the problem when it could be an installation error?
Culturally, the quick response to that is we are accountable. In Austin, from a product experience, we take it very seriously. The first thing we do is we point the finger at ourselves. Like, what about the experience made it this happen? I don't know, you.
Yeah, that's pretty much what I was going to say. Anytime there's an issue like that, I definitely take it personal from a product design perspective and the experience. One of the things that I'm really excited about that I forgot to mention during the last question on the technology development is self-commissioning and auto detection of errors. So on the wiring side of things, if a contractor miswires or forgets to land a wire, the control panel should tell you that. And it should be a clean user experience to, hey, go swap this wire with that wire or things like that. So we can add extra sensors as long as it doesn't affect the reliability to detect to miswires and accelerometer, like we mentioned earlier, to detect some things like that. So.
Talking about the accelerometer on the board got me thinking about predictive maintenance programs. Have you guys looked into anything like that?
So kind of going with the theme of moving technology around, right? These motors we've been purchasing for 14 years, they're very advanced. They have accelerometers inside of them. But what pains me is seeing how many of them just get thrown away, right? You mentioned you replaced 4, and are they still in your building? Yep. Right now? Damn. So that right there haunts me. We have an owner of a building. He got a great warranty experience, sounds like. But he's literally just sitting on broken, busted plug fans, and they're literally going to end up either in a landfill or maybe Q-PAC might just go pick them up or something since you're so close. But that haunts me. So what we want to shift the technology and put it in the right location. So I say that to say that in an MPF, and we're not there yet. I want to reiterate, we got a lot of work to do. Okay. For instance, internally when we ship a one-pack, right, which someone here was showing me one. It's just a single plug fan, right? That is not a multi-motor plenum fan, right? So we're in this weird transition as a company, right? We've been taking ECM fans and building a bigger system out of them for years, but we have to solve it. It's going to take time. It doesn't just happen instantly. So I say that like the MPF should be so reliable that you're not worried about features and benefits inside of the motor and that added expense, right? Because it's a throwaway component. And I meant to say this earlier about what differentiates the MPF versus a fan array. I mean, we treat it as a cohesive device, right? Like replacing a motorized impeller or a plug fan is just a subcomponent of our system. So yeah, we'll have an accelerometer and we want to track, like we want to know, it's an early warning of something is wrong. If a bearing failed and the thing is vibrating, we want to at least have right now we don't have something that tells us that's happening. But as far as, some people will say, hey, if I knew that the motor bearing, because a lot of the manufacturers here today, they have very advanced technology inside these motors. I mean, they can predict the bearing life of the motor, and that's great for certain customers. And I want to reiterate today so that you don't leave here with any doubt that we're very focused on comfort cooling, large, highly occupied spaces. This type of technology from these manufacturers is put into many different markets. Some of those markets may want to know that one of the bearings on one of these plug fans is going to fail early. I currently do not believe that feature is a requirement of the MPF. I think that it should be as reliable as possible and cost-effective as possible so that the replacement is as affordable as possible, and we don't need the technology inside of the motor. So I hope that answers your question. Yeah.
With a fan array, it doesn't matter because you have enough redundancy that if one fails, you're still not going to really fail. You're just going to be sort of uncomfortable, basically. So
yeah, not even uncomfortable. The goal would be that it's sized. Redundancy is kind of a. I've started to hate the word, right? Because if you go look at the actual definition, it says more than you need. Like the actual definition is you have more than you need. That's like, I mean, we don't operate that way. We're very efficient, like we want to be. You need exactly what you need. It should be a system that can lose a single motor and you're still meeting your duty point without a lot of the compromise that a current fan array comes with. And there's a bunch of them. There's a lot of it. So just solving the problem a little differently. But any other questions?
Anyone else?
We need
out
some
there?
questions.
Got a couple more minutes. Yes. Go ahead, Tyler.
Let's see which one. And I briefly talked to Matt about this on the side actually, but when I see an EC fan array or a multi-motor plenum fan, EC motors, the big red flag that goes up is that they sometimes introduce harmonics into the system. I was wondering, and we've usually applied harmonic filters, either a passive filter or an active filter from brands such as like MTE or TCI to try to help mitigate this. We've run into issues with certain types of filters and certain types of EC motors in the past. I was wondering if you guys plan on doing any testing upstream of your fan controller to incorporate some of these types of harmonic filters, because I know a lot of critical facilities that they're going to question that.
Yeah, that's a great question. So for me, whenever I hear the word harmonics, there's two sides of the coin that I worry about. There's one, we don't want to be adding any additional harmonics to the system, and two, we want to be resilient to any harmonics that are already on the grid, right? A lot of these buildings that we're going into already have some level of existing harmonics, so we need to be robust enough to maintain the airflow in these existing environments, and we need to make sure we're not contributing, making the problem worse. So, yeah, okay, sure. Yeah, I've got like a third grade level understanding of harmonics, but basically it's dirty power, or like you have a bunch of inside the motor. There's a bunch of switches switching on and off, and that can cause distortion on what used to be a perfect sinusoidal wave becomes all choppy, and so that's what we're talking about when we're talking about harmonics. So. Yeah, we are definitely in the discovery phase again on harmonic filtration. We're trying to figure out where the best point to apply harmonic filtration is. We've explored some other solutions in the past where you apply a harmonic filter upstream of our control panel, and it would filter the entire system downstream from that. We've talked about applying a harmonic filter at every fan controller level, so sizing it for up to 9 motors that fan controller is controlling, and then also at the motor level itself. So you can buy EC motors that have a filter already built into them. So it's about putting the atoms in the right spot and figuring out what is the most efficient and resilient way to do that. We believe that the future path that we're going to take is inside the fan controller. We think that's the best place to put it. We're hiring right now some power electronics engineers that are hopefully going to develop that future for us and have that filtration and that robustness built into the fan controller without any additional equipment, without any additional startup. I know sometimes these filters are really difficult to commission. You got all these different options, and yeah.
And just to add to that, I mean, our intention is, and it's going to take a lot of effort, is that when you use Q-PAC MPF, you know, you're not concerned about this problem. Like, we just eradicate the problem. I mean, that would be, but it's not going to be easy. And he's right. There's a lot of different places that you can solve it. You know, going back to the motor, you know, they make motors right now that have filtration, right? But again, it goes back to it's a throwaway item, and it started to really bother us, or me personally, that, you know, these are run to failure, right? The plug fans, they run and they fail, and then you completely replace them. So it better be as lean and affordable and simple as possible, in my opinion, because I don't think it's going to be more likely to be serviced over time. But that's kind of the opinion-driven aspect of what we're doing at Q-PAC. So, but just so you know, like, I mean, we're dead set on like customers that have buildings not having this issue. We need to mitigate harmonics, yeah. Yeah, any other questions?
Check. I think we're up to, I was just trying to get the math on it, but we're up to 91 buildings that are a mix of MOBs and medical facilities and things of various sorts. And they're all traditional belt-driven motors, Baldor kind of stuff with drives. Of those, we've surveyed chill water valves, all kinds of boiler systems and things, and of the motors and VFD combinations that we've surveyed, I think it's over 64% are running at a moderate or significant impact to energy because they're not running efficiently. The drive isn't referenced correctly. The motor isn't tensioned properly. It hasn't been greased or serviced in a long time. There's so many variables with the VFD motor system that cause these things to underperform over time. And I know there's debate, I was talking with Salem earlier about the ECM motor versus the traditional drive motor and the energy efficiency there. But just from a practical real world standpoint, when you're looking at that many building samples and that many of those VFDs and traditional motors have that much inefficiency just over time. I feel like that's a selling point that maybe we could be discussing in the market, and just something I wanted to mention. So just real world thought from me. So thanks.
Yeah, I mean, it's kind of a half joke, but we treat the plug fan like the new belt, right? I mean, because I do believe, like, if you tasked me with replacing a belt on a 100 horsepower blower, I don't feel like I'm properly trained. So straight up, like I think I would do it wrong. I don't think I would get the tensioning right or something. I mean, I'm sure a lot of them, you know, we talk about changing a belt, but changing a belt is relative. There's ways to do it 1 out of 10 stars, and then there's ways to do it 10 out of 10 stars. And it leads, and greasing, you could do 1 out of 10 stars greasing, or you can fully understand how a bearing works and grease it right. I mean, when you talk to facilities, you get a 25-year-old who's never greased a bearing in their life, you just completely shred and destroy a brand new motor in like 6 months. So it's not that you greased it. Like, yes, I greased it in the checkbox. It's actually more complicated than that. It's not trivial, but with the bolts, the way we're attacking this, it should be where you can send your generalist, right? You can send someone who is not a 25-year veteran HVAC tech, and you know that it's gonna be done right. You know that there's very low risk. Did you have a question?
Yeah, and I don't have the math on it, but there were hundreds in those buildings of drives that were in hand. So where's the energy savings for drives in hand? Anyways.
Thank you for that. That's awesome insight.
It's a really good thing that when I look. It's a really good thing that when I look at the Multimotor Plenum Fan, I don't see any belts. I don't see any bearings. I really don't see any maintenance. So we've kind of hit on some of these interesting problems and facets. We talked about, you know, the labor shortages, and we talked again about the industry veterans are leaving, and so this is a product that's going to help keep that, or excuse me, help that transition so that your customers, your end users, your students, your inmates can be comfortable, so that all of our day-to-day, the comfort cooling that we move forward and that we expect continues to move forward during the times of the ability to find, labor that's in a bit of a shortage. And so I do kind of want to start adding a little bit of closing to this. We appreciate you guys being out here. The Q-PAC Multimotor Plenum Fan, I think, is going to be a wonderful addition to everyone's facilities. And we hope that, Davis, you can start implementing them. Michael, we appreciate you continuing to purchase them and to standardize. Kevin, please rip these things apart and help us be better. And I know that from our engineering team, that's exactly what they're going to do. And for everyone here, for all you guys, anything we can possibly do to help you out, to continue to help implement these in the field, any type of information, any type of suggestions that you think will make this product better, we're here for you. We're all partners. We're just trying to change the game, create a new fan in a new category, and just bring some happy airflow to the world.
Thanks, Leah. Good job. Yeah. And anybody that wants to chat afterwards, I want to make myself available. I'm sure a bunch of us would love to keep the dialogue going. So thank you. Thank you all for coming.
Nice job.